So what is polymorphism? What is the definition? Basically it means many forms, right? So in Java and other OOP language, polymorphism allows the same interface or the method to behave differently based on the object or the context, right? So we can have two methods with the same name, right? So that is also many forms, but their functionality will be different. Okay, what is the key idea? Different classes can be treated through the same interface. Behavior will vary based on the actual object types. Okay, so name can be same but behavior will be different, right? So we are having two types. First is compile time polymorphism. That is what? Method overloading. It happens at compile time. Okay, what is the we can say use case, key idea? Same method name but different parameters. Okay, let's say one method we are having void sum. Okay, in this we are having two parameters x and y, correct? And we are doing the sum x plus y, let's say. Okay, in the second function we are having same name sum, but we are having three parameters now, y and z, and z. So basically we are having here two parameters, method name is same, but parameters count is different. Here we are having three parameters, here two. Okay, so we will get at the compile time which method we are calling, right? So next type is runtime polymorphism. That is called method overriding. That happens at runtime. Let's say subclass changes the parent class. Okay, let's see the example of this. Let me clear this. Okay, so let's say we are having one parent class, let's say class animal. Okay, and thus we are having one method, let's say sound, void sound. Okay, here we are doing what? We are printing sysout what? Makes sound, right? And there is one more class, that is, let's say dog class dog, which is a child class of the animal class, right? So it will be extends what? Animal, right? So animal is the parent class, dog is the child class. Now we are overriding this method. Which method? Sound, and we are providing different definition. That is what? Sysout barks, right? So here what we are doing? We are overriding it, right? This is the parent class, parent, this is the child class, and we are having the same method here and here. This is what? Overriding. Okay, we are overriding the method from the parent in the child class and giving the different definition. Okay, so this is the example of overriding. Got it, guys? Now here two terms are there. First is compile time. What is compile time? The second is runtime. Okay, let's see this. What is compile time? What is runtime phase? Okay, so compile time phase, compilation phase. So this is done by Java C, that is the Java compiler. This is the part of JDK, Java Development Kit. Okay, now it converts the .java source code into the class bytecode, right? Basically what is the functionality of this compiler? This is the definition of the compiler, right? So this is the compilation phase, Java C. Now what happens here? What it will check? It will check the syntax, right? It will ensure that code is valid, no undeclared variables or no mismatched method signatures. Basically it will check our syntax is correct or not. Okay, this is at the compile time phase. What else? It will check the type, ensure method calls and overloaded methods match correctly, right? So what we are calling and what we are having the method, they should be same, right? And what else? Overloading resolution. The compiler decide which overloaded method to call based on the parameter types. As we have seen the the example of this method overloading, right? We are having the same method, same name basically, but the parameters are different, right? So it will decide at the time of compilation which method we will call. Okay, it will call, basically our function will call. So this is the compile time phase, right? Understood? Okay, so this is the compilation phase, right? These are the things we will be checking at the compilation phase. Okay, now next is runtime phase. It will load and execute the .class bytecode, right? Now what happens here? Class loading. JVM loads the necessary class files into the memory, right? This is basically the feature of JVM, Java Virtual Machine. Okay, and what else? Basically this also is the part of JRE, right? We are having JRE, that is Java runtime environment. So JVM is the part of JRE. Class loading is there. Object creation. So JVM allocates the memory for the object. Method dispatch. Now, so JVM will decide which overridden method to invoke using the dynamic dispatch, right?